Perfect. It says it recording. So,
Okay, good. So
so
now you
one of my
so
first
now you have
questions,
to
sorry, was
decide whether you want to use Windows or you want to reinstall Ubuntu on the computer.
I don't have a problem with making a partition and installing Ubuntu if you think it's going to be better for the workflow.
I think it will be better because you only have 32 gig RAM, and then if you run Windows, it will need some RAM space as well. So it will be better because you don't have too much RAM. So the best will be just install Ubuntu in a new partition. Yeah, so I think that would be the first thing you need to do after the meeting.
Okay.
Yeah,
I'm writing information.
and then
Okay, I had a question on which programs for the analysis I should be using because
yeah, so there are several. Let me see. There are several programs you need to install. I think I can send you a list because it is not just one software. It's a list of softwares you are going to install, and then yeah, because the first thing. So if you yeah, so if we start, maybe we can start with using RSAM for gene expression analysis. Let me send you the link.
perfect. Now what I'm going to do, I'm going to join the meeting from the desktop as well, so I have I can access the links.
I see.
Launch meeting. And are you
Yeah.
currently
So
in New York?
in Massachusetts. Yeah, I recently moved to Massachusetts.
How are you finding how are you finding Massachusetts?
Yeah, I don't have much opportunity to go out because we usually stay at home. Yeah, because of COVID, so it's
Sure.
like we didn't have the chance to visit the city too much. Yeah.
Did
So
you
I send you a link for RSAM right now.
perfect. Yeah, it says I'm joining from the other computer. There we go.
Yeah. Okay, good.
Join.
So you can click on the link. It will lead you to a GitHub website.
Okay. Is it under chat? Yeah.
Yeah, so that is where you can download this. It has some instructions for how to install the software under Ubuntu.
Mm-hmm.
And yeah, so you just need to download to your Ubuntu, and usually so are you familiar with the Linux data, the structure, the
I
directory?
I will be honest, I've installed Ubuntu in the past. I've used it to play around a little bit, but my knowledge is very limited.
I see. Yeah, so I think the best would be uh, maybe I can I don't know if I can simulate a Ubuntu. Let me see. Yeah, I think the most difficult thing at the beginning is to figure out the configurations. Yeah, so you have to
Linux
mm,
shell on Windows 10.
yeah, so I think when you use Ubuntu, you will have better idea how to install softwares.
Okay. And
Yeah, yeah, because I think there is an easier way for you to do this. But what I based on what did previously, I usually use a command line uh, software, and I think you could try if you yeah, I think command line is still the best. Some people use R, and I never use R for this analysis previously, but let me see.
The link that you sent me for the Linux bash on Windows 10 is to be able to use Ubuntu directly from Windows, or is it to create a partition?
I think you can directly use the Ubuntu on Windows to run this.
Okay.
Yeah, it is just that I think for RSAM should be okay, and RSAM you probably need a lot of time. It will take some time to run. So maybe I can give you an example, and then after you install the RSAM, then you can try this script on the files you have.
Sounds perfect.
Yeah, let me see.
And I was reading about this RNA-seq analysis, and will I be using things like string tie, HiSat2, and Subio platform? I've read. I don't know if they're familiar to you.
Yeah. I have used the string tie. I'm using string tie as well, but I usually use star aligner instead of HiSat.
Okay.
Yeah. Oh, so I can send you the star aligner as well. Yeah, because star aligner is for doing sequence alignment. And then let me see. Yeah, and HiSat is doing the same thing. Yeah, it is just that the star seems to be more, more familiar with star, so I use star.
Okay.
Yeah, you can use HiSat. Because for splicing analysis, the software I developed is based on star aligner, so you will have to use star, I think.
Sounds perfect. You tell me what to use, and I'm going to learn how to use it.
Yeah, there's another page. There is another page showing how to do alignment. Let me share the link. Yeah, this one seems to be good. So are you familiar with how the RNAseq is done?
I understand the process of how RNA-seq works, and I understand the output data that it gives you. I understand that you need to trim the reads because there's going to be small reads that we don't want to include in our analysis, and those reads in the
the trimming is actually optional. You don't have to trim because when you do alignment, the star or HiSat aligners, they will not match the unmatched part. So some sequence on the read won't have alignment. So it is called a soft clip strategy. So you will let me share my screen. I can try to show you some slides. Let me see.
And I also had a question on the genome to use as reference.
Yeah, so you are doing human genome, right?
It's mouse genome.
Oh, mouse genome. Okay, so
yeah.
For mouse genome, you can go to Ensemble.
Actually, I have a question because the organism is mouse. The experiments were done on mouse, but it has a human gene. In that case, what would I do?
Yeah, so for that, you need to create a customized gene annotation, including the human gene. So it depends. So if you are interested in the gene expression of that human gene in your RNA-seq data, then you need to create a customized gene annotation. But if you don't care about the expression level of that gene in your RNA-seq data, then you don't have to do anything.
Because it's mostly as a control, the human gene, because we know what the effect of these various treatments are on the gene of interest. But the whole point of the RNA-seq is to see on a global level if the treatment is causing change in alternative splicing of other genes. So focus on other genes, but as a control, have the gene of interest to show that the treatment results in a change in splicing event?
Yeah. So I mean, in the end, eventually, are you going to report this gene, the expression level of this gene, the human gene, or are you going to compare the human gene with other genes?
I'm going to compare the human gene with other genes.
Oh, I see. Yeah, then you need to create a customized gene annotation. Yeah, but I'm going to show you the more basic way to download the gene annotation. So if you go to the Ensemble website and you can go to the FTP.
Yes.
Let me see. Yeah, there is a. If you go to, let me send you the link. It will be easier. There's the chat. Yeah, I couldn't see the chat. Yeah, I'll send you the link.
Perfect.
The FTP site. Yeah. So basically, you need to first create. So can you see my screen?
Yes.
So from this FTP, the Ensemble has the genome sequence, also has the gene annotation. Like here, the first one is human, and then your organism is mouse, right? So you have to download two files. One is this DNA file, the FASTA file here. Yeah, and then the other one would be the GTF file here. So this GTF file is a gene annotation file.
Yeah.
And then this FASTA file is the chromosome sequences.
The ones the sequences is one is all the information relating to what the genes are.
Yeah, so the GTF basically contains the genomic coordinates of each gene and each exon. And then you will, so based on this gene rotation file, the software you are using will know where the gene is, like which read should be grouped as a gene, right? So yeah, so if you go to this, yeah, it doesn't, let me see. Let me use Safari.
And this.
Yeah, so when you go to the FASTA file folder, you will see something like this, right? And then you will download this.
Primary assembly.
Yeah, usually this one, primary assembly. Yeah, this one I can copy the name. Yeah, I cannot find the text. It's okay. I will send you the name first. Yeah, this is the DNA, and then the other one would be the gene annotation file. I think basically when you do the gene expression analysis, you will need these two files to begin with. Let me see.
Does splicing require more files?
I think for splicing is splicing is the same. You use the same files, but for your study, you need to use a customized one, I think. Yeah, so it'll be a little bit more complicated.
It's not as simple as downloading one and adding one gene from the other genome reference.
Yeah, you have to download the mouse and human, and then you have to cut the part from the human gene and then include it in the mouse genome.
Okay.
So you have to do it for both the FASTA file and also the GTF file.
Mhm.
Yeah. Let me copy this. Yeah, so I'm, oh, sorry. I think I click on the,
Mouse one, yeah.
yeah, I should click on the mouse one.
It's okay. Like I will be able to find this information once I get there.
Yeah. So in the chat, I send you the name of the files. So the DNA will mean the genomic DNA sequence, and the GTF file will be the gene annotation file.
Perfect.
So in the let me see if I can find the RSM. Yeah, I think the first thing you need to do is to install the RSM software. So you have to download from the GitHub website. Do you know how to download?
Yeah. We have to install Ubuntu. I'm gonna have to install the star liner, download the reference genomes, and from
and then download the RSM as well.
okay, you have
And also, I think RSM you need to use Bowtie 2 as well.
Bowtie 2. Okay.
There's another software called Bowtie 2. Let me find the link.
I've heard of Bowtie 2. I didn't quite get the what's it called, the SAM.
Can you say again?
There was another program which I'm missing. You said Bowtie 2?
RSM.
That one, yes.
Yeah, I think in the chat I sent you the link already. There is one from GitHub RSEM. RSEM is the RSEM.
Okay, there we go. Yes.
Yeah, so you have to install RSEM, Bowtie 2, star, and SAM tools. Let me see SAM tools.
I have a lot of learning to do.
Yeah, so you have to install each software and then see if you can run the software. Yeah, so it will be
All of
try
these.
and error at the beginning.
Perfect. Sorry for interrupting you. And all these programs I should download directly onto Ubuntu. Work from
Yes.
Okay.
Yeah, Ubuntu. So you have to create a new partition and install Ubuntu on that, and then download all this software to the Ubuntu partition, and then you have to install this software first.
Perfect.
Yeah. Let me see if anything you need to download as well.
Oh, this link that you sent is very helpful.
Yeah, I sent you the Bowtie 2 RSM and also the star aligner.
Perfect.
Yeah. So you have to install all these. Yeah. So I can briefly tell you the RSM is based on, it's kind of coupled with Bowtie 2. And then the star aligner is coupled with another software that I developed for splicing analysis. So at the beginning, you only have to install the Bowtie 2 and the RSM. That part is for gene expression analysis.
Okay. So getting started with the gene expression, once I get an idea of how that works, move on to analyzing splicing.
Yeah. Gene expression is a lot simpler because one gene only has one value, right? But splicing is a lot more complicated.
Yeah.
Yeah, and then I think I will send you the the commands how to add the human gene.
Oh, that would be
Do you
fantastic.
know how to do that?
No.
Yeah, so I can, but you have to let me know which gene you want to add, like which human gene you need to add into
I,
the mouse gene?
it's called SMN2, survival motor neuron 2.
Oh, SMN2.
Yes.
Yeah, I see. I think I may have the.
Because it's the one that Craner will have worked with.
Yeah, I see. I will.
Because humans and mice both have SMN1, but only humans have SMN2. So
Yeah,
when they were working with, when Lucho went to Cold Spring Harbor to work with the transgenic mouse line, he used
yeah.
a line that had the SMN2.
I see. I see. Yeah, I see. Okay, I will do that later, and I will send. Yeah, I think maybe I can just create these files for you, so it will be easier. Do you want to learn how to do it?
I want to learn everything you're willing to show me.
Okay. Yeah. So maybe I can send you the script, and you can give it a try, and then
Mm-hmm.
you can try all this software, and then when we meet next time, you can tell me all the problems you have.
I'm sure there will be many.
Yeah, yeah. I think at the beginning you can start with RSAM, because RSAM is kind of the more basic.
Mm-hmm.
But even for RSAM, you have to install several softwares as well.
Okay.
Yeah, we have the Ubuntu has to have uh, the C compiler, I think. Let me see. Yeah, because I have installed this like a long time ago, so yeah, so I don't remember all the details now. Yeah, but I think it shouldn't be very difficult.
Okay.
Yeah, so I think the GitHub page I send you, it has all the instructions how to install, and then uh, how to run this program. So RSM, there's two major steps. One is to create a index for sequence alignment, and then the second step is calculating the gene expression level. So let me share my screen so you can kind of get a rough idea. So when you run it, you know what you are supposed to do. Let me see. Yeah, so can you see my screen?
I can see it. Yes.
Yeah, so this is the RSM instruction page,
Mm-hmm.
right? So you will see some examples. So this part is how you install the RSM, and after you download the zip file from here, there's a release.
Yeah.
This is version 59. Yeah, so you just download either one to your Ubuntu home folder, and then you can unzip it, and then when you go into the folder, you can type this make, and then just follow these instructions. Yeah, and then install the. Have you ever installed any this kind of software before?
No.
No. Okay, so
But I understand the lines of code that I need to write to be able to install this.
yeah, yeah, I mean, ideally, you just need to copy and paste.
Yeah.
But but for example, this part, when you install, you have to specify a
Directory.
folder.
Mm-hmm.
Yeah, so this usually you can put it under your home folder,
Mm-hmm.
and then this my name is something your account name
Perfect.
underneath Ubuntu, and then the prefix will be the place where you actually install the software. And then if you type is exactly like this on Ubuntu, you will find the RSAM under here. It will be under this home directory, and then a my name directory, and software, and then bin directory. Yeah, so if you can find this RSAM under this folder, do you know how to show the files under Linux, like because it is not like it's not a GUI interface. It's like you have to.
It's like speak the writing on your command line.
Yeah, for example, yeah, for example, we under the terminal. I mean, when you install the Ubuntu, you have to open a software called terminal. I'm using Mac, but Ubuntu has the same software called terminal, and then under this terminal this is where you put in all the scripts, all the commands.
So when I will
And
be installing a RSM, I need to do it from this terminal.
yes. So you have to under, yeah, let me, I think there should be some web page you can read first. Install software. Yeah, I hope I can find something has some graphic illustrations.
I'm sure with a lot of reading, I'll be able to.
Yeah. So I think first you need to at least understand how to use terminal under Ubuntu, because that will be the main software you are going to use. Yeah, and all the others you can ignore at the beginning. But terminal is something you need to get familiar with. Yeah, I'm trying to see. Yeah, install software. Yeah, I think you can find some information on the internet as well.
I am very familiar with Googling and looking for videos, reading. So
Yeah, that's good.
I'm
That's
going to
good.
learn to teach myself how to do this, the kind of this basic parts.
Yeah, I think at the beginning, the first thing you need to do is install Ubuntu and then find a document teach you how to use the terminal software. And then under terminal, you need to learn how to install these softwares first. Like for example, the RSM will need some, you can try to install RSM. Also, you have to install, I think C++, you may, I don't know if Ubuntu will include this by default, but if you don't, then you have to find how to install the C++ compiler. And Perl should be installed by default. And I think R you have to install by yourself as well. Yeah, so at the beginning you have to install several softwares to get RSM to run.
Okay.
Yeah. So R is, you can find R.
I've used R in R Studio in the past.
Oh, good. Then you can try to find the link for Linux as well. Let me see. Yeah, the easiest yeah, so I think you can try this, install R by yourself. And yeah, because I'm thinking about if you want to try the Anaconda as well. Anaconda is a kind of a software packaging software, like it kind of provide a a platform for installing all the softwares without worrying about the different versions of the software. It's kind of
By the installation steps.
yeah, it's kind of make installation easier for
Okay.
you. But I guess you can uh, like play with the terminal first, and
I think it's a
then you
good thing to
kind of
learn. Yes.
install RSM, and then eventually, if necessary, I can show you an account.
Okay.
Yeah, this is kind of something more popular now for installing softwares, because when we use a workstation or use a server, we want to install something, and then very often it will require root permission to put the software you install under a specific directory, and then that directory can be may not be accessible for all the users. May only the administrator has access to it.
Yeah.
So the Anaconda is kind of provide a interface. You can install all kinds of software without the permission of the administrator.
Okay.
Yeah. So under Ubuntu, there you will create a administrator account and also your own account, and then you should put everything under your own account, and then don't put too much. I mean, usually we don't use the administrator account so often because we don't want to kind of damage the system, and then uh, we may accidentally delete some important files, then you have to reinstall the Ubuntu again. Yeah, it will be painful. But I think at the beginning when you are playing with it, it's fine, because if you may damage something, you just need to reinstall, then it is okay.
Okay.
Yeah. Yeah. Okay. So I think yeah, because I'm planning doing this like once a week. Once a week. How about once a week every Saturday?
Sounds
And then
perfect.
you can do
Gives me
that.
time to try some things out, to read, and then come back with a couple of questions.
Yeah. Like every week we can have a meeting, and then you can kind of tell me what you you cannot what kind of problem you have, and then I can try to figure out how to help you. And yeah, because I think at the beginning you have to get familiar with the Linux system first. Yeah, I think the Ubuntu, you have to install Ubuntu, and I think the best practice for you is to install RSM. Let me see. Yeah.
Just to see
So
if
if
I've
you,
gotten kind of the steps straight. Start with installing Ubuntu,
yeah,
partition, installing the terminal software to be able to install all the other softwares.
yeah,
Need C++, Perl, and R, of which one of them might just already be installed.
yeah. Perl should be already installed.
Okay, Perl should be installed. We're going to need Starliner, which we use instead of HiSat2. And I'm going to need to create a custom genome of the mouse genome with a human gene.
Yeah,
And I need the FASTA files and the GTF files of both species. And then I'm going to use Bowtie2, RSM, SAM tools, and C compiler.
yeah,
This okay.
yeah. Sounds good. Yeah.
Plenty to start with.
Yeah, so that's something you can start with. Try to learn how to install the software. So yeah, so I don't know. Do you think that like a meeting once a week is enough for you, or you think that because usually during the weekdays I have to work, so I usually have to have time during the weekend. Yeah, yeah,
I think once a week is good because it gives me plenty of time to try as many things as possible. Also
yeah,
working and I'm working too. I'll be in the lab doing other things in parallel. Uh,
yeah,
I like the idea of meeting on Saturdays.
yeah,
Okay with you?
yeah, yeah, yeah. To me, it's okay. Yeah.
Perfect.
So I think I will try to find yeah, some kind of documentation. I think that there must be somebody have created a kind of simple guideline for beginners
I've been looking for tutorials online. Uh,
for RNA-seq analysis.
yeah,
Yeah, that's good. Yeah, so you should learn how to understand the data behind the reads, how the reads are generated. Yeah, so
sounds good. Lots of work
yeah.
to do, but I'm
Yeah, so
excited to
yeah,
learn.
yeah. I think at the beginning you need to play with it. Yeah, so I need to think. Yeah, I'm thinking about if that would be enough for you. Yeah, I think we can try at least the first week and then see like how you feel about it, and then how much more materials you will need. So I can try to find the materials for you to learn.
That would be
Yeah.
fantastic.
Yeah. Because otherwise the another way is I think after you get familiar with terminal and then the Linux directory system, then I can show you how to run it under my screen.
Mhm.
Then you will have kind of like a better idea how to run it, because the Linux directory system is not a may not be intuitive to you. So you may not, so you at the beginning you may have to kind of adapt to the logic the Linux system is using.
I'm sure it'll be something new to learn.
Yeah. So I think let me see if I can find something else as well. Mm. Yeah, so the as a backup, if next week you still have too much problems, then we can think about a alternative like uh like because I know that we can also use something I created, and then you just need to deploy the what I have created. It will be
User
make
friendly.
it may kind of make the installation maybe easier. Yeah, but I think it should be okay. I think for so far all the software you plan to learn, plan to install, it should be okay. But you can try, and I will explain to you like why it has to be done like this, right? Because sometimes some steps you may not understand why you have to do it, and then so you got stuck over there. Yeah, so you can so another good habit is that you should document all the commands you have execute.
Yeah.
So usually I will put it into a text file, and just something like you can create a text file, and just let's say you create a folder, and then into the and then cd space folder means that you get into the folder. Mkdir
Mhm.
space folder means that you create a folder
Okay.
under whatever directory you are, and this is going to the folder, and then you can ls means we will show all the folders, all the files under this folder. So these are the four very basic commands. The pwd will show you where you are. For example, if I type PWD, can you see my screen?
Yes.
If I type PWD here and I hit enter, it will show me the
Okay,
path. Yeah, where I am right now, right? So, and then if I type ls, it will show all the files under this folder.
mhm.
Yeah. So, yeah. So I'm thinking about because so one way is that I can give you all this software you need, and you can try to figure out how to do it. And then the other way of teaching is that I can guide you through each step on my computer, and then there will be kind of slower. I think it will be kind of slower. It will take a lot of time to do that. And then if you can kind of learn by yourself, and then if you like ask me the questions you have, I think it will be a lot faster.
Sounds good. I feel like
Yeah.
it's a better idea to the first option to see how much I can learn on my own, and any questions I have we can go through together. And
I think that will be more sufficient.
mhm,
Otherwise, it will take it will be, I mean, it will be a lot to cover, and it will take a long time. And but it's okay to do that too. Yeah. So so we can let you kind of try it the first week, and then see what we get next week, and then we can decide how to move forward.
sounds good. We can adjust according to the needs.
Yeah. Because I think some people can kind of get an idea and then learn this by themselves. So yeah, and then like myself, I learned this by myself. So you don't really have to go to a class or something, right? So
I'm sure there's a lot of information available.
yeah, especially you cannot, because of COVID, you cannot travel,
Hmm.
cannot go to the class. Yeah, so and I think there should be some. Let me see if I can find uh, I forgot the name. Okay, yeah, this, I don't know if this one teach
Oh,
you.
I know Khan Academy.
Yeah, this one, I don't know if they teach you Linux. Yeah, I think there is a Linux tutorial. Oh, it doesn't have it. Yeah, so it's yeah, I think only teach you HTML, that kind of stuff, the web pages.
What, are there any kind of languages of code that I'm supposed to learn for this?
For doing this analysis, you don't have to learn any programming language. You just need to learn how to install and execute, and then how to configure these softwares.
Hmm.
And then in the end, you just need to understand how to use the output files. And then for programming language, you probably need uh, learn how to visualize the data, like visualize the table. But I believe that you probably know how to visualize a table of data already.
Yeah, like
Yeah.
a big Excel full of information of expression.
Yeah, right. So it's basically like but yeah, but for the gene spatial analysis, you probably need to uh, so you haven't learned any programming language yet.
No, as far as
So
using RC.
I think we can start with something that doesn't require a programming language,
Okay.
and then we will see uh, what language you need to learn. I think there are several languages. If you have time, if you want to learn right now, the most popular uh, language is Python.
Okay.
And yeah, Python, let me see. Uh, I think here we should teach you Python, I think, because yeah, so but this is JavaScript, it's not Python. Yeah, there should be a lot of these materials for Python. Yeah, but I don't use Python.
You don't use Python?
So
What do you use?
I use Perl. I think I use Perl, which is a kind of older language. Yeah, I think it will. Oh yeah, W3 schools. Yeah, so this is a good place for you to start. But I think the programming language you will need a class, attend a course because there are a lot of things to cover. It's a little bit more complicated, and then it's a kind of a brand new logic to many people's brain. Like when I was teaching the programming language in college, the many students they don't understand the
Yeah.
logic, so they kind of just memorize whatever is written on the book, and then they just write whatever they remember, but they don't really get the idea. So the programming language will take a longer time. But if you want to just process, just get some output file from gene expression and splicing, it will be a lot easier. And yeah, yeah. We will. I think we will see how it goes. Yeah, so we can plan on it. Yeah, and then I don't know how much time you have for this kind of training.
I'm going to be seeing this week. I'm returning to the lab to the pet, but I should have plenty of time to dedicate to this.
Yeah, no, I mean, are you planning to have this training like for 1 month or 2 months? Like
Uh,
how long?
to be honest, as much time as I need to be able to efficiently process this data, but at the same time also kind of hurried, rushed, because I know Alberto wants to see the results. So try
Yeah,
as quickly as possible, but doing
yeah, yeah,
efficient.
yeah. So I think we should skip the programming language at the beginning, and
Hmm.
then we start with how to run the softwares,
Okay.
right? And
Yeah.
then you get some output file, and then how to interpret the output file. So that would be kind of fit your needs
Hmm.
properly. And yeah, so yeah. So I think at the beginning you just need to install Ubuntu and then get familiar with terminal and then install software. Yeah, and then next week we can talk about either how to install the software, or we can talk about how to execute the softwares.
Okay.
Yeah, yeah,
Sounds
yeah,
like a great idea. We'll see how I get on with this work. Got some
yeah.
homework to do.
Okay, that's good. So this is your first year of PhD or the
Second,
second year?
my second year PhD.
Oh, okay, good.
5 years in here. It's much longer.
That's normal. I think usually people need 5 years, usually 5 years, I think.
Yes.
Four to 5 years.
Okay.
Yeah, yeah.
I
So
lost 8 months now because of COVID, because the lab was closed from March.
yeah, I see. Yeah, I think many, like even in I'm from Taiwan, so some of my classmates, they took them like 7 years and for PhD, and also there are a few people they spent, I think, 9 years for for even for bioinformatics, it's it's yeah, I think like 4 or 5 years is kind of fast. It's not
Okay.
a it's not a long. I mean, it sounds like a long time, but
It gives
but
me
it's
hope.
yeah, okay. So we can schedule the meeting next week, next
Do it.
Saturday. And then,
Same.
so the same 1 p.m. works for you, right?
Works perfectly for me. I'm 2 hours ahead. So it's
Ah,
1 p.m. for you is 3 p.m. for me.
okay, that's good. That's good. Yeah, so we can do 1 p.m. Saturday next time, next week, and then we can talk about like how much you have tried, and then yeah, and then we can start from that because once you install the Ubuntu and then the terminal,
Mm-hmm.
then you can share your screen with me, so I can kind of tell you what you should type and then what kind of small mistake you make. Yeah, because under a Linux system, like every detail is important, right? Sometimes it's just a
A capital
space or a
letter.
typo. Yeah, so it's like very tedious.
Okay. It's good to
Yeah.
be meticulous.
Okay, good. Yeah, good to. Yeah, it's nice to see you, and then we will talk next week.
Sounds perfect. Very much
Yeah, and let me know the
in the future.
Luis how the like Luciano, how is like how is he recovering? Yeah, I hope he's
Yes.
coming back soon.
I'm sure he will. He's very strong.
Yeah, okay, good.
All right. Thank you very much for your help. I'll see you
Okay,
next Saturday.
okay, see you.
Out.
Bye.
Bye bye.
Bye.